and more aligned with local hardware and regulation. And then came the price cuts. DeepSeek slashed API pricing by up to 90%. For V4 Pro, one report said the cost per million input tokens dropped from around 14.5 cents to just 3.6 cents. In China, pricing updates published on April 26th showed V4 Flash cached input costs falling to 0.02 yuan per million tokens. The business-focused V4 Pro model saw promotional cached input pricing drop to 0.025 yuan per million tokens. That is ridiculously low. And that changes the game, because the bottleneck is no longer creation, it is workflow. Higgsfield is sponsoring today's video, and they just introduced something called Higgsfield Canvas. It's a node-based visual workspace where your entire creative process lives on one infinite board. So instead of generating things one by one and ending up with a folder full of disconnected files, everything stays connected. You can start with a simple idea or mood board, generate a character, pass it into another node to animate it, then upscale it, relight it, adjust angles, and keep building toward the final output without leaving the canvas. And the key difference here is visibility. You can actually see the whole pipeline, what references were used, which models generated each part, and how everything connects from start to finish. That makes it much easier to tweak specific parts instead of restarting everything from scratch. It also brings multiple models into one workflow, from image models like GPT, Image 2, and Soul, to video models like Seedance, Kling, Wan, and Veo. So this feels less like using separate AI tools and more like working inside a proper creative system. If you want to try Higgsfield Canvas, link is in the description. All right, now back to V4. One user, Yang Hua, from a Shanghai gaming company, said he used V4 to manage files and spent only 0.56 yuan. He said that was less than a tenth of what he paid using a previous US model, while the efficiency and capacity felt almost identical for his use case. Now connect that with what is happening inside big companies. Enterprise AI usage is exploding so quickly that people are now using the term token maxing. Disney reportedly had some engineers using Claude around 51,000 times per day, which forced the company to build an AI adoption dashboard to track usage. Meta reportedly had an internal dashboard that turned into a leaderboard where employees competed over who used AI the most before it was shut down. Visa spent 1.9 trillion tokens in March alone. So when a strong model becomes much cheaper, this does not just save money, it changes behavior. Teams start using more AI, more workflows get automated, more internal tools get connected, more companies start asking whether they really need to pay premium prices for every task. Val Bercovici from Weka summed it up with a simple point.
Rivaling top closed source models. All right, so let me show you some of the major benchmarks. Here we have MMLU Pro, which is knowledge and reasoning. We can see here in the dark green bar, this is DeepSeek, with orange being Opus 4.6, purple being GPT V4, and then in the stripes, those are the new models, Opus 4.7 and GPT 5.5. But what we're seeing is, although it is slightly behind here, it's right up there, okay? And remember, it is a fraction of the price. Here, GPQA Diamond, same thing, Sweetbench verified. And basically what you're seeing across the board is, yes, it is behind, but just a little bit. And that's the real story here. Most use cases, the vast majority of use cases, do not require the absolute frontier level intelligence. And the fact that DeepSeek is so much more efficient and so much cheaper is actually the problem for the United States. And so let's talk about cost, because that is really what we need to be scared of. And if you're not sure why, I'm going to explain. Let's look at the cost first. This is AI model price versus performance. On the y-axis, we have intelligence. Just think the higher, the smarter. On the x-axis, it is the price. The more to the left it is, the cheaper it is. Cheaper is better. And so what you want is to be up here in this top left. You want to be as cheap as possible and as intelligent as possible. And so what do we see? We see GPT 5.5, which was just released at the very top. We have Opus 4.7 right next to it. And I'm just measuring intelligence right now. GPT 5.4 extra high right over here. And then we have DeepSeek V4 Pro, a little bit behind, a little bit lower on intelligence, but much, much cheaper. And then look at Flash down here. Certainly a big drop in intelligence, still really good, but this is an absolute workhorse model price right here. This is pennies per million tokens. Now I want to show you how the rivalry between the US frontier labs and Chinese
percent, not 100. Keep that in mind when you benchmark. DeepSeek is the other direction. V4 is a sparse mixture of experts. Pro has 1.6 trillion total parameters, but only 49 billion are active at any moment. That makes it cheap to run. They're reportedly using Huawei chips, not NVIDIA, which cuts another margin layer. Their CEO says they priced just above cost. The lesson is blunt. Architecture did what money couldn't. Sparse attention, mixture of experts, FP8 quantization. These are published papers anyone can implement. Every open-weight lab gets the same efficiency gains. Every closed lab still has to match them while also paying NVIDIA. Is open weight actually good enough? Honest answer.
As one of the government's major white papers. So the focus for Chinese companies, including DeepSeek, is really on efficiency. It's by using clever software optimization techniques to squeeze more performance out of what they have at the moment. And I think if you look at the characteristics and the technical competency of that model, that clearly illustrates that China is developing, I think, a real lead in software optimized models and in cost down. And if you look at the pricing in terms of token pricing that they're charging external clients, they're still, compared to the leading Anthropic models, they're an approximate 80 to 90% discount. Now, I would suggest that the pricing is a loss-leading price. There's obviously some degree of subsidization going in there, but they're also benefiting from this cost optimization, which allows them to push ahead in terms of pricing. So, China is clearly emerging as a global leader in software optimized models. It lacks access to NVIDIA, and therefore its ability to compete on frontier model developments is curtailed. So the strategy, given the constraints they work
or do agentic coding, then Pro is the one I would test first. Now, the other important thing is that both of these are available as NVIDIA NIM endpoints. NIM stands for NVIDIA Inference Microservice, and in simple terms, it means NVIDIA is giving you a hosted API endpoint that runs the model on their GPU infrastructure while still exposing a normal developer-friendly API. And the best part is that the API is OpenAI compatible. So if your tool supports an OpenAI compatible provider, you can usually connect NVIDIA pretty easily. The base URL is integrate.api.nvidia.com/v1. The chat completions endpoint is integrate.api.nvidia.com/v1/chat/completions. And the model names are DeepSeek AI/DeepSeek V4 Pro and DeepSeek AI/DeepSeek V4 Flash. So don't confuse this with the official DeepSeek API.
Actually playing with the model than what resides beneath. But with that, we can see right here that this model, for its size, and we are focused on the Pro model right here, this is a 1.6 trillion parameter total model. It is a mixture of experts model with 49 billion parameters active and a context length of 1 million, which is quite a long context length. So all of these specs, well, mainly the 1 million context length is very interesting. And I have to stop myself from just focusing on this Flash model because this is very exciting for somewhat reasonable local setups. But for now, we're just going to focus on V4. This announcement post that we're looking at now was just, I followed a hyperlink on the DeepSeek homepage and it brought me here, and then the browser is just translating this from Chinese to English. So just keep that in mind when we look at this. But the main point here is to take a look at this benchmark JPEG. Now, I personally never pay too much mind to the benchmarks because I just like to test the models and see how they perform. But we see here that this is being compared to, although the older version of Opus, which is 4.6, we're now on 4.7, and then the older version of GPT, which is 5.4, we're now on 5.5, but I can't excuse this one in specific, being that this did just come out like 12 hours ago, so that's fair. And we can see against Gemini 3.1 Pro High as well, this is pretty comparable to these and even beating them in some specific benchmarks here. And again, I don't pay too much mind to this, but it's just very interesting.
Last week, we got the long-awaited brand new model out of DeepSeek, DeepSeek V4. DeepSeek V4 is nearly state-of-the-art. It's open sourced, and it's got a 1 million token context length. Now, here's the thing about this model. It's not quite as good as the state-of-the-art models, right? These are, well, kind of the last generation of state-of-the-art models here. We now have Opus 4.7 and GPT 5.5. So it's kind of comparing it to the last generation of models, but we can see it's really dang close in almost every single benchmark. It's right up there with the state-of-the-art models in math, right up there with state-of-the-art questions and answers. And if you look through all of the benchmarks, it's just really, really close to these state-of-the-art models here. Now, this is important, again, because this is open source, open weight models. Now, they're still a little bit too big to run on consumer GPUs, so you're still likely going to use them on DeepSeek's cloud or some other cloud service. However, the biggest differentiator and the reason all of the big model companies sort of freak out about this stuff, and when models like this come out, it sort of has a little bit of a shock on the stock market, is because of this pricing down here. This is basically almost as good as the best models out there. It's got the 1 million token context window, so you can put in a ton of text and receive a ton of text back from it. And it cost $1.74 per million tokens input and $3.48 per million tokens output. If we compare that to GPT 5.5, GPT 5.5 is $5 per 1 million tokens input and $30 per 1 million token output. And even GPT 5.4, it still looks pretty cheap compared to that. $2.50 per 1 million token input, $15 per 1 million token output. And this model is roughly as good as GPT 5.4. If we compare it to Claude Opus 4.7, $5 per million token input, $25 per million token output. And if we look at Gemini 3.1, that one's $2 per million token input and $12 per million token output, but then it gets even higher when you increase the amount of tokens. With that in mind, looking at their pricing, companies are able to get nearly the same capability at a significant discount. And because these models are open, they could theoretically put them on their own supercomputers in their offices and run them locally and have all of the security and safety and privacy benefits of having these local models. So these open models are catching up, and they're also being trained for a lot.
This constant low-grade exhaustion for the engineering teams.
And that physical struggle is exactly why DeepSeek had to relocate their operations to Inner Mongolia.
Right. Ulaanbaatar was a strategic necessity. They transitioned from being this light asset algorithm lab in a city office into a heavy asset data center builder.
By moving there, they can exploit natural environmental cooling. The ambient temperature in Ulaanbaatar frequently drops to minus 20 degrees Celsius.
Freezing air is a lot cheaper than industrial air conditioning.
Exactly. But more critically, that location puts them right near the nodes of China's ultra-high voltage transmission grid.
Which means cheaper power.
A lot cheaper. They procure green energy at rates approximately 50% lower than the tariffs you'd pay in eastern hubs like Shenzhen or Beijing.
Which is fascinating when you contrast that physical reality with what's happening in the United States right now.
Oh, the power constraints in the U.S. are becoming a massive bottleneck.
Yeah, the tech industry is facing such severe power shortages for their AI data centers that they are actively exploring restarting dormant nuclear plants.
Like the 3 Mile Island facility.
Exactly. They are looking at recommissioning a nuclear plant solely to feed the energy demands of artificial intelligence.
Wondered why.
If the true bottleneck in the AI race is no longer writing better code, but simply getting access to industrial scale electricity and thermodynamics.
But the management of that power and heat is intrinsically linked to the physical properties of the silicon inside those racks.
Which brings us to the geopolitics of all this.
Yeah.
Because you can't analyze the architecture of V4 without looking at the U.S. government export controls.
Right, specifically the International Emergency Economic Powers Act and the Export Control Reform Act.
These were explicitly designed to restrict Chinese entities from acquiring advanced AI accelerators.
Most notably, the NVIDIA H100 chip.
So why is the H100 so critical? What makes it the gold standard for this kind of work?
It comes down to interconnect bandwidth. When you are training a massive 1.6 trillion parameter model, the mathematical matrix is way too large to fit on a single GPU.
It has to be fragmented across thousands of chips, right?
Thousands of chips, all working in parallel. And the speed at which these chips share data with each other during the backpropagation phase, that dictates the overall speed of your training run.
So if they can't talk to each other quickly, the whole system bottlenecks.
Exactly. And because of the export controls, DeepSeek was blocked from getting H100s. They were forced to train the V3 and V4 models on the NVIDIA H800.
Which is the export compliant variant.
Right. It's a specifically degraded chip. Yeah. The raw compute power is slightly reduced, but the real issue is the NVLink interconnect speed.
The communication channel between the chips.
Yes. On the H8,
you can apply like immediately. Okay, so subagents never have direct lines to each other. So if you have like a research agent over here, it cannot directly talk to the reviewer agent. It has to go through the coordinator. And so that is pretty clear. And the coordinator is going to own the routing. So it's going to decide how to route things. Context sharing. So what will be shared? So the research agent is not going to be aware of what everyone's doing unless the coordinator passes that information along and it gets injected. So it really won't know. And any kind of error handling, any kind of observability, anything like that. Okay. And obviously that would make it.
But it is something to be aware of. There's a much cheaper, faster, and higher quality way to do this. And that's where we get into multi-agent orchestration. So this is all about having a coordinator and a bunch of different specialists that come in together and tackle a problem. And we'll go through sort of what that looks like. So here's a visual. There we go. Here's a visual illustration of what a multi-agent orchestration structure looks like. So you might have the human here talking to a project manager agent. The project management agent's responsibility is to orchestrate between a series of specialist agents. So for example, say we wanted to build a website.
And every agent framework out there. Now, let's take a look at OpenClaw because it's probably the best real-world example of an agentic AI assistant in action right now. OpenClaw is a free open source AI agent that was created in late 2025, but now it is one of the most popular projects on GitHub by total stars. So let's learn how it works. So the OpenClaw agent runs on a local Node.js service on your machine. So this could be your laptop, a virtual machine, a Raspberry Pi, wherever you want your personal assistant to be available. Now, it follows a hub and spoke model that's centered around one singular part, which is called the gateway. Now, the gateway is really important. It's a control plane, and it's always on as a WebSocket server that handles things like message routing, session management, the ability to create multiple agents, and as you'll see in a second, the usage of tools. But how do you actually communicate and access this main gateway? Well, there's two methods, including the UI and the CLI to actually manage the gateway. But when you're sending requests to your agent, you have messaging integrations through various channels. So these are going to include examples like Slack and Teams, as we talked about before, but also Discord, iMessage, pretty much any kind of communication platform that you want to reach your agent with, you can. But the way that is actually standardized to something like OpenClaw is through these different adapters. So the adapter takes in these different types of incoming sources of data into one unified internal format that can then be provided to that gateway. Now, we talked about the agentic loop that is used to assemble the
from disk, inject the relevant files, and then work from there. So Ralph loops or projects like Gastown or Archon are all examples of systems that act as outer harnesses. In this article, it said that the harness acts like a cybernetic governor, combining feed forward and feedback to regulate the codebase towards the desired state. That feedback mechanism is one of the most important parts of this process. There's a very useful distinction between guides and sensors here, where the guides help steer the agent in the right direction. So these are anything that tries to make the agent's first attempt better. So your agent might read from an agents.md file, or you may provide skills and playbooks and examples that they can work from. But the AI agent is not always going to get things right. And even if so, not necessarily according to your own behaviors and rules. And that's where the very important feedback loop comes in. And these are referred to as sensors. So we might have deterministic computational based sensors such as linters and types and schemas. So for example, whenever your coding agent creates code, you can run those through deterministic checks without using AI at all, and then feed that back to the model. And one of the main arguments made within this article is that these computational type checks are heavily underused by AI builders. Of course, you can also have sensors powered by AI, known as inferential sensors, such as you can feed code generated by an LLM into another call to an LLM, ideally another model, where it can act as a judge, and then that can be fed back into the model. and humans then continuously steer and optimize the components of this outer harness. If we go back to our OpenAI article on harness engineering, they've run with this type of concept, where the agent is called in a Ralph Wiggum loop until all human reviewers are satisfied. Running an external Ralph Wiggum loop, not the one built into Claude Code directly by the way, is a very simple example of an outer harness. It can just keep spawning Claude sessions again and again and again through brute force iteration until a certain goal has been met. And other outer harnesses can just take this thin orchestrator concept as a starting point and bring it many steps further and potentially in many different directions. Archon is a great example of a tool that allows you to create your own outer harnesses, which can enforce your agents to act in a certain deterministic way. It already includes a lot of out-of-the-box workflows, and it even allows for parallel executions of tasks. We use this inner-outer harness distinction as a
Let's do another cool thing here. So the next thing that you would want to do with your agent is maybe evaluate, right? Evaluate how they are doing. So maybe we can ask the coding agent to come up with different eval criteria for Caveman agent and run them for us to see how it's working. And this is really important for anything that you're putting in production to really have evals ready. And now with Agent CLI, your coding agent can do that for you. So meanwhile, this command runs, what we can do is go to our browser. So I just opened this link in our browser. Here you can see this Caveman agent being deployed. You can see the dashboard. You can see the traces, identity, all the production ready features just plugged in through a single deployment. You even have a playground here to test it out. And the same thing that we saw in the local ADK web UI is also available in the Cloud Console. You can look at all these logs here. You can see the Caveman agent replying. And this service is now accessible for anyone, everyone. You can just like share the deployment endpoint and things could be built on top of that. So we are here. Next thing, let's look at the status of our evals that we asked the agent to generate. We asked the agent to generate like 20 eval criteria for, we asked the coding agent to generate 20 eval criteria, lots of agents. It's like building agents with agents. Generate 20 eval criteria, and here you see it has generated all these eval criteria. And the best thing about this is it won't only generate the eval criteria, but it also test the agent against those eval criteria. It'll take a minute or two to do that. We can come back to it later. And the next thing that you could really do here is extend your agent. I want to go back to the docs and show you how you can extend the functionality of this simple Caveman agent that we built through simple prompts. All the way to the bottom, we have built the agent. We have already deployed the agent on Agent Engine. We have asked the agent to write evals, and it is already running them for us. Next thing that you will want to do is add tools to your agent. So to add a Google search tool to your agent, all you
The AI orchestration layer is basically the beating heart of Fab. It's in the middle. It's where all the intelligence takes place. So when we're talking about orchestrating outcomes, you need a certain place of logic. And all this logic we have built into the orchestrator layer. So this is where the decisioning takes place if an interaction needs to be handled by a human or by an AI. But this is also where the business rule sits, where we orchestrate the outcome. So not just, is this the best solution, but is this the best solution for this specific client, for this specific customer? It's an interesting question, right? Because in the end, I think the threat creates the opportunity for change. If you look at it in the market, I mean, I've been in this market now for over 2 decades, and the adoption rate of new technology has always been quite slow. So you consider it a threat, but I think it just progress. And we've seen this before, right? TP has a long history, and every time there was a new pivotal change by new technology, we've seen to overcome that. So I think I don't consider it a threat. I consider this more as an opportunity because it gives us a motivation to do these changes. And change is there, and it's there to stay, and it creates great new possibilities, which is a win-win situation because it's good for the clients, good for the customers, and it's good for us. In the end, you see there's a lot of possibilities. AI is not, it will take some of the jobs, but it will create a lot more new jobs. Think about just a thing like prompt engineering. So, 5 years ago, nobody ever heard about prompt engineering, and now it's potentially one of the best paid jobs in AI world. It's an evolution of the
agents and harnesses. In simple term, a harness is a fixed architecture that turns a model into an agent. So if you think about modern LLMs or models, these are just one-shot text generators. You ask a question, it answers and stops. A harness is what gives it the ability to take action, see the consequences, and keep going until the problem is actually solved. So think of a model as the engine and the harness around it as the car. That's what makes an agent. So a really good example of this is agentic coding tools like Codex, Cursor, Cloud Code, Windsurf. These are all harnesses. Each one started from a concrete problem
and that you need to make. What does make a world of difference is what you build underneath. So the underlying system has a name, and we're, as mentioned, calling it the Agentic operating system. And that's why we built a free program to help everybody build one for themselves, regardless of which tool they use. And more of that at the end. But a few things that you need to do and know today. First of all is why the Agent OS is the most important and most overlooked concept in practical AI. We then will go over quickly the 7 layers and what actually goes in each one. And we'll talk about how to build the first version of this week using the running example of a chief of staff agent. So your agentic operating system has 7 layers, and you can see them on screen. And all of your agents will run on top of these layers. And each agent is basically inheriting the whole foundation. So the OS is what makes agent effective, regardless of which tool you use and regardless of how many agents you add over time. You build the OS once, you maintain it, and then every agent you add gets better because the foundation is there. And we're going to walk through
or blog articles. So what we've done then when we've built this skill is made it completely modular so that other domains and skill systems can actually pull from that, which is when we start chaining them together, which is the next step. And this is something I rarely see people cover, and I rarely see in other agentic OS. I want you to start thinking about your skills, not as single isolated skills, but as part of a full pipeline or process. So you don't build a copywriting skill to use it in isolation. That's not going to save you much time. You're still going to manually then need to schedule your content, find out about the topics. What you're actually going to do is chain multiple of these skills together in a chain, as it sounds, something that we call skill systems. So you might actually have a scheduled task, and you can do this through the Claude desktop app. And that scheduled task is going to conduct your topic research. From that topic research, another skill is going to actually write a script, maybe for a short form video, maybe for a long form video. And then that is actually going to then either create the video or do something in the next step. We might have a separate scheduled task, a separate skill system that is all about repurposing the content. So it understands that a video has been posted. It then uses the transcription skill. It's then going to go and actually repurpose the content. We might have a human in the loop step where we review, approve, and make changes. And then from that, it goes and posts the content. So actually, I want you to start thinking about skills as these modular components that you piece together on a schedule so that you don't have to be there when these skills run. And that's really how you get your time back, right? You're using this as an autonomous skill loop. So skill A is going to complete. We might have that human in the loop step. Skill B is going to continue to iterate until it's complete. And each one passes to the next with one skill orchestrator, actually kind of a meta skill, chaining all of these together to finally achieve an output. Like, for example, inside our community, we've been voting on what skill systems to build out next, which are chains of multiple isolated individual skills together. So like social media content generation, social carousels, ad generation and monitoring, SEO blog content generation or GAO, page optimization. So it's something we're really focused on for our own Agentic OS, and something that you should be heavily focused on if you're looking to actually get back your time to. And they don't need to be completely autonomous. They can have multiple human in the loop steps as well. Now, single tasks and chained workflows are kind of one thing, but you need to make sure when you're
buried in the launch coverage. The model went backward on web research. BrowseComp, the benchmark for multi-page synthesis and retrieval, dropped from 83 to just 79. If you're wondering who leads there, GPT 5.4 Pro leads that benchmark by 10 points at 89 right now. Gemini 3.1 Pro leads by 6 and change at 85. Meanwhile, on Terminal Bench 2.0, which measures command line task execution, the kind of work coding agents do really consistently, Opus 4.7 trails ChatGPT 5.4 by nearly 6 points, 69 versus 75. So if your agents rely on web research or live in the terminal, you should benchmark your specific workflows before you migrate. Ultimately, the model got stronger where Anthropic invested, in coding, in agentic persistence, in vision, in enterprise knowledge work, and it got weaker where it didn't. This is not a uniform upgrade. It's a directed optimization, and it's worth knowing before you make big decisions about migration. And here's a detail that connects to the cost question.
Workflow used to be an afternoon, but I want to show you one more thing before we move on, because this is the feature that honestly made me say, wait, really? The first time I tried it. I've already done all the analysis in Excel, right? So normally if I wanted to turn this into a slide for a meeting, I'd screenshot the chart, paste it into PowerPoint, fix the sizing, add a title, maybe retype key numbers. 10 minutes of busy work. I'm in PowerPoint now, blank deck. I open the Claude sidebar just like I did in Excel. I can do that here too. And because Claude shares context across Excel and PowerPoint, it already knows what I was doing. So I'm going to say this. Create a one-slide executive summary of the vendor spending analysis from the Excel file I was just working on. Show the top spending categories and call out the total spend for the quarter. And there it is. Let me close this down. Clean slide, titled, key numbers, pulled straight from the Excel analysis, top categories called out. I didn't copy anything. I didn't paste anything. I didn't explain what I wanted to analyze. Claude already knew because it was in the conversation. And that's the part that I think is genuinely new. It's not just Excel getting smarter, it's the whole Microsoft Office suite working together through one conversation. If you work in Word and PowerPoint alongside Excel, that shared context is probably going to save you more time than any single feature in Excel sidebar. Okay, let's get back to Excel. Now, let's talk about errors. If you've used Excel for
ways that we can iterate, we can click on edit, and that would let us actually edit things ourselves. So maybe I don't want to call this a founding designer. Maybe we want to just call this the founding graphic designer, and I could go ahead and do that. And what's important here is when you make these changes, Claude applies them. But what this does is it helps you actually be more specific on your changes, and it will save you it will save you tokens in the long run. Because if you wanted to prompt all this by natural language, you could, which is awesome, but there's more room for error there. Whereas here, we can actually click on the exact specific element that we want. We could change the sizing, we could change the color, and we can be more specific by doing the actual edits. What else we can do is we can use the draw. So let's say we don't want, I don't know, maybe we want this logo to be bigger. So I would draw a circle around this, and then I could just type and say, I want this to be larger. And then I could send that off. And what that does is it injects that drawing. Oh wait, it said it couldn't capture it. What happened? Okay, let me try that again. I could circle the logo down here. You can't see it because this thing covered it up. And then I could just say, I want this to be larger. And when I send that off, it basically injects that screenshot into the chat right here. And so it knows what I just circled and it sees the comment that I left. It's a little bit buggy down here, unfortunately. And now we'll go ahead and actually implement that change. So it says, the user circled the small tally mark inside the... Interesting. Okay, so that actually didn't work. It seems like, yeah, that didn't work here. The draw might be a little bit buggy right now. Keep in mind, this is in research preview, so you might see a bug like that. I, in the past, have been using draw and it's been working fine. But that's just another example of like, maybe you don't even need to draw, because if it's a specific element, just highlight it. You know, if I wanted this to be bigger, why don't I just grab this and make it bigger myself, you know? Draw is probably more useful for something that doesn't actually have an actual like div tag or an actual element. So let's say, you know, maybe we want to go to like the last slide. And let's say this background was like a gradient or something. Maybe there's a really weird, the gradient's too dark right here. And I would circle this and say, hey, can you make this section a little lighter? That's probably a better use case of the draw compared to drawing around something that actually exists as an actual element. And what's cool here, kind of interesting, each one of these tally marks is its own individual component that we could change, which is kind of interesting. I could change the color of just this one if I wanted to. So that is pretty nice. I'm not going to do that. I want to make sure I don't do that change, but that's pretty cool. Now that's a little bit annoying. There's not like a reset button, unfortunately. So, or like an undo. So if I wanted to change this back, I would have to grab the actual color from there and come into here and then change that. And now I could edit that and it would fix, but that was a little bit like, I think that there should definitely be like an undo button, or maybe I'm just missing that. And then we have the ability to add tweaks, which is pretty cool. This basically just means that we could change the way that the slides actually look. And we could do this rather than prompting, we could just do it in an interface. So let me show you. This looks really nice. There are some slides that might feel just a little bit bland though. So I might want to be able to add some more color or just a bit more of our brand feel on top. So could you give me a couple different tweaks that I could play around with for this whole slide deck? And what I like about this is there are
using it to read the markdown files. Clicking into the root claw.md file, there are 3 things I want to highlight here. First, under memory system, right up top, there's a line that says, at the start of every session, read memory.md before responding. And there's a rule after that that says, when I say remember this, write the information to memory.md. And these 2 sentences are why Cowork has persistent memory. Second, the routing map section contains a table that tells Cowork which workstation folder to load for which type of task. We haven't built any workstations yet, but when we do later on this video, this is where they'll be all listed. And third, references. These are pointers to files in our root 00 resources folder that Cowork only reads when it needs to. This is one of the ways to keep token usage low. By the way, I had to cut a lot of detail to keep this video within 20 minutes, but
there's really no set limit on the number of files. Now let's do something that chat can't do at all, which is work inside your browser. Here's a scenario. Say your business has a car loan and every month your payment covers both principal and interest. Only the interest is tax deductible, but your bank shows one payment. So when you log this in QuickBooks, you need to split it into 2 lines, principal and interest. Now you could read the loan statement and type these numbers in by hand, which is fine for one loan. But what if you had 50 of those sitting in your bank feed? Here's what you need to do. First, install the Claude Chrome extension. You'll find a link to it inside the resource guide in the description. Then head back to Cowork and click the plus button in the left sidebar to start a new task. From the exercises folder that's also in the resources guide, choose number 2, accounting. This folder has 5 loan statements which correspond to the 5 transactions we see in QuickBooks. Before we get into the prompt, make sure you've selected only the accounting folder. Cowork likes to select multiple folders by default. Now, here's the prompt. We tell it to use the loan statements in this folder to categorize transactions at a specific link. We then give it rules on how to split the transaction between principal and interest. Let's start this off and set up the browser and Claude side by side. Claude starts by opening a new tab and it's attempting to open QuickBooks in the browser. I'll allow it just on this website so it doesn't try to go somewhere else. Let's switch to the new tab and see what Claude does. It's already made it into QuickBooks, and notice that I logged into it ahead of time, so I didn't have to give Claude my username and password. It takes its time reading the page and trying to figure out how to interact with it. About 2 minutes in, it makes it to the split page, and then it fills out the amounts and the categories. Now, the good thing about Claude is it keeps checking itself to make sure it got the task right. It's not infallible, but it gets pretty close most of the time. This is the type of task you can leave on autopilot and get back to other work or do something else. That's case number 2 where Cowork beats chat. It can
Granola and Asana are connected and ready. So here's the prompt for this build. I'm asking it to build a Kanban style interface where it pulls in my meeting notes from Granola and extracts all the action items. Then it adds each of those to the board. It will also pull in a list of teammates from Asana, and I can drag them onto whichever task needs to be assigned to them. Then when I'm finished assigning, I can click a button to push that all to Asana. So plan mode, new folder, send. So I'm just gonna skip through the planning and approval since we've already covered all of that. Then I'll show there were a couple of errors along the way. So I screenshotted those and fixed them. The push to Asana button needed a fix. Then I needed a project selector, just standard iteration. Now here is the finished prototype. So I read through the recent meetings that I gave it access to, and it pulled out every action item. All my teammates from Asana are listed at the top. It pulled those in on its own. Then I select the project from the dropdown. Now I can just drag people onto the tasks to assign them. So I'll assign a couple to me. Then I'll use Saj for another person to assign them to. So I'll push that. Then it says they're queued up. I can say push it. Should be done. So we'll go check Asana. And here are all 4 of the tasks properly assigned. All right, now I'm not going to go through and make every part of this function perfect.
Mail client. Now let's look at another really common use case, summarizing information. I'll start a new chat right here in the top left-hand corner. You'll notice when I hover, there's a shortcut key. I have a dense sales report I need to read. Instead of going through the entire document, I can upload it to Claude to get a quick summary or ask questions about it. Right over here, I could click on the plus icon, and here I could upload a file or a photo. Or my favorite method, I could simply take my file and then drag and drop it into the chat. There, I see my file. Down below, I can now enter in a prompt. So let's say to summarize this and give me the key takeaways. Then over here, let's run that. Claude pulls out all the most important points and presents them in a clean, easy to read format. And look at that. Revenue hits $482,000. Like Mama always said, there's money in the cookie business. Now, this works with all kinds of files like documents, PDFs, or even spreadsheets. So far, we've been using Claude like a chatbot, writing.
Going a little bit to show you guys what's actually possible with this. So what's really cool is now that you have these Playwright CLI automations that can do things in your browser and it can save your cookies. So basically you stay logged in. You can actually start to automate things when you use the desktop app. Now you could also use something like Modal or Trigger and just deploy those automations there. But I like to use the desktop app for my scheduled tasks because I get the more agentic ability. Because when these scheduled runs actually run, it's an agent literally like you see in Claude Code walking through what's going on. So for example, I have basically created this bot in my school community. So his name is AIS Agent. And as you can see, it's posting things like daily news roundups and it's responding to all of its notifications. And it even today made a happy birthday post for me, which I didn't tell it to do. It just knew information about me. And it did this completely autonomously. So I've got it doing things like every day engaging with school wins. So if I click on today's run, you can see that it shows me what it engaged with and it ran all these commands. And it basically just shoots over this prompt and it invokes the skill to do this every time. I've also got it doing the AI news roundup. And I've also got it responding to all of the notifications in school. It looks like there's actually one running right now. We've hit some sort of error, but because this is agentic, it's going to keep trying different things in order to make sure that we're actually able to get this to go through. And remember how I talked about with Playwright CLI, you have to use the skill more and more or run the script more and more in order for it to understand what to click on and where to submit things. And it has to learn how the actual UI of, in this case, school works. And all of these automations I have running in a headless browser, meaning when I have my computer open, I don't see the tab pop up and I don't see it happen. But right now I told it to go into that happy birthday post and respond to all the comments on that post. And so now it is pulling up this browser. It needs to figure out how do I actually navigate to that post that I made. So it's going to its notifications and it's just going to look through the notifications and click on those and respond to them. And as it goes through this agentic loop, it starts creating new tools because one time someone said, hey, AIS agent, can you please vote on my poll? But the agent couldn't figure it out. So what it had to do is it had to figure out what does it actually mean to vote and where do I click? And once it did that, it turned that into another script. And then it was able to make sure that its skill was updated so that in the future, it was a bit more autonomous and could actually vote on polls. Cool. So what it did here is it made a to-do list of all of the different comments that it needs to respond to. So here's the comment and then here's the actual reply that it's going to make. And now it's launching up this browser and it's going to
interconnected, and finally before it is validating at every stage, at income verification, credit score, fraud, and risk and compliance, and final validation done, and your final approval is done by an agent and send a feedback to human for review. Now, this reviewer, he is not aware of the policies. He is not aware of the policies, and he is very new to the system. Let's understand a case where he's very new to the system. Now, what is he trying to go? Upon this final approval, he has to go and verify with the policies and come up with a decision, whether this is risk or whether he can approve. So additionally, he will try to verify with the policies. Okay. And his review can be depend on whether he has seen the similar score coming from his past approvals in the bank. So he can have any additional check from pulling from the database. That's where your MCP comes into the picture, and he can have any other tool calling, and he can validate additionally by calling the LLM validators. That is nothing but LLM as a judge. One LLM will try to judge the other response coming from the another LLM. So that's how the entire traces could be. And
if you use that.
Yeah, so basically skills in general are there to help LLMs perform certain tasks better, right? And of course, as we kind of use MCP in Claude or your other coding agents, they don't know so much about NNN from the get-go, right? So what MCP basically does is that it gives tools to these coding agents to build NNN workflows a certain way. And these skills, or this skill, kind of optimizes on some weaknesses that we still have with these LLMs on some of the tool usage, right? So, for example, it in the past preferred using a code node over a set node when trying to do some data structure and so forth. So the skill is just optimizing on some things that maybe coding agents otherwise are slightly confused about.
Yeah. And so we are going to be providing a skill that makes LLMs better at creating workflows.
Exactly, in combination with MCP.
Yeah. All right, cool. Do you hear that?
I'd be curious to hear what you think in the comments down below. Now, the next major trend that I'm noticing is more related to the product side of things, but that's something called agent experience, or AX. Now, we used to have UX, right, which was user experience, but now agents are more and more actually consuming the software that we use on an everyday basis. For example, I have like a Monday dashboard or an Asana dashboard or my Google Drive, and rarely now am I actually going in there and manually doing something. I'm purely communicating with an AI agent that then takes the action for me. Now, this is becoming a more and more important design discipline and a design decision that teams have to consider. How do I design my software in a way such that AI agents can consume it and use it? And we've seen that with MCP, we're seeing that with plugins, adapters, connecting to tools like OpenClaw, and this is becoming more and more popular in the industry, and something that I think is going to be a pretty interesting kind of avenue to dive into, or something where there could actually be a lot of jobs where you're head of agent experience, right? Or you're an agent experience developer who's really responsible for making sure that this software is adaptable or usable with AI agents. All of the major tools out there are coming out with MCPs, updating them quickly, and even having, automatic prompts that you could just copy and paste into your tool that will set everything up for you. Really interesting trend. Again, curious to know what you guys think about this, but something I'm noticing a lot that's been ramping up just over the past few months. Now, I have a few other more
with like 8 tools, but then what happens if you added like a few more, or a few more, or a few more, or a few more? Or a few more. And now you're like, I want to give an agent access to our whole API surface. And, well, that ain't gonna happen. Why is that not gonna happen? You've exploded a context window of the agent. You've like completely annihilated it. This is 1.something million tokens. And this was the problem that we came across.
You can always change it later. Now hit send. Now look at this. Codex doesn't just start coding, it comes back with questions, like a product manager would. Who is the user? What kind of events? Where does the data come from? How should the matching work? This right here is the difference. Old AI tools, you give a prompt, they spit out something random. Codex acts like a teammate. It wants clarity before it builds. Codex even names the brand for me. 3 options come back. Common room, near folk, third place, I am going with near folk. And we move on. Now the part you saw at the start. Not going to ask Codex to design my screens directly. Instead, going to use a tool called Paper. Paper is a canvas design tool, and it talks to Codex through something called MCP. Don't worry about the term. Just know that Codex can now drive Paper like a car. So I tell Codex, hey, use Paper to design the screens for near folk. The Paper file is open on my desktop. Go. And now watch this carefully. The cursor is moving on its own. Codex is literally drawing the screens for me inside Paper. Hero section, buttons, text, the conversational chat interface for the AI concierge, the marketplace screen, all of it getting designed live. Be honest with me, the first time I saw this
to install itself. Let's dive deeper into GitHub Actions for Cloud Code Review. This YAML file is absolute core of the autonomous reviewer you are building. This is a display name of the workflow. This is what developers will see next to the yellow spinning circle or green check marks inside the GitHub pull request UI. This block defines the trigger. It tells GitHub to run this pipeline exclusively on pull requests. It specifically fires when a pull request is newly opened, updated with the new comments, marked as ready for review, moving out of draft status, or reopened. This ensures Cloud reviews the latest code, not outdated commits. This commented out line are your first cost optimization technique. In real enterprise, running an LLM on a pull request that only updates the README file or CSS file is a waste of API tokens. By commenting pass, you restrict Claude to only boot up when actual application logic. Declare the start of the specific job internally named Claude Review. This is the second cost optimization technique. If you have 100 developers, AI reviewing every pull request gets expensive. This is block allow you to target the AI reviewer specifically at junior developers, external open source contributors, or first timers who are statistically more likely to introduce security flaws, while skipping pull requests from trusted senior staff engineers. Tells GitHub spin up a standard fresh Ubuntu Linux virtual machine to execute the workflow. This enforces the principle at least privilege for the GitHub Actions runner itself. Instead of giving the runner full admin access to the repository, it explicitly limits it to read access for cold and pull requests. The ID token write is a modern security best practice that allows a runner to authenticate securely with external systems like cloud providers, using OpenID Connect without needing long life passwords. The first step of the job, it uses GitHub's official actions to pull your repository's code into the Ubuntu runner. Fetch steps 1, a crucial performance tweak. Instead of downloading the entire Git history, it performs a shallow clone, grabbing only the absolute latest commit. Invokes the official Anthropic Cloud Code GitHub action. Inject your secret API key safety. The plugins line tells the actions to fetch the specific code review MCP plugin from Anthropic official marketplace. Context injection, it uses GitHub action variables to dynamically inject the exact repository name and pull request into your prompt so Claude knows exactly what is looking at. I modified prompt a bit. Right now it focused on security. Rule 1 and 2 eliminate noisy formatting complaints, lowering false positive rates. Rule 3 forces the AI to be helpful rather than just complaining. Rule 4 is the Agentic command. It forces Claude to invoke a specific MCP tool to post an inline comment rather than just dumping text into the console. Rule 5 ensures the pipeline doesn't spam developers.
You guys. Now let's start by understanding as where exactly does this latency live? Now this is the part that most engineers skip and they actually shouldn't. See, a RAG request is not one operation. It's a pipeline of 8 stages, and at every single one of them is a place where your latency can hide. So it's a place where it can hide over here unless and until you
don't assume this rich knowledge, so they completely discard it. We model this as a part of the search problem. So instead of embedding just the query, we jointly embed the reasoning choices. And we also train a retriever from the ground up, well, fine-tuned, but explicitly designed for this task of being able to infer the implicit agent user context from their reasoning choices, from their reasoning traces to improve retrieval for agents.
Yeah, and I think the results you found with this custom trained retriever for this are amazing, and it's something we'll dive into. I love that you just brought up that connection with personalization in human searching. We're really big on memory at Weaviate. We're launching Ngram, and we've been like thinking a lot about this kind of.
So now let's talk about observability. Oh, I realize we have 10 minutes left, so I'll be fast on this. So for observability, we like to use OpenTelemetry in order to output all of our traces. In order to do that with LangChain, we are going to use that LangChain Azure AI OpenTelemetry extra. Remember that we installed that, and that has this enable auto tracing function in it. So we call that enable auto tracing function in our code. You can see. Actually, we have a few more options that I passed into it. Where did I put it? Enable here. So enable auto tracing. So I passed in the connection string. This gets auto injected into the container by the platform. I said, I want you to configure Azure Monitor. So it's going to export to Azure Monitor based off that connection stream. It's going to record all the content. That includes tool calls and arguments, which could be sensitive. So you don't always want to record them. Trace all lane graph nodes, and then I gave it an ID. So that's the setup that we're going to do that's going to emit traces using OpenTelemetry in a standard way that's going to work with App Insights and also as well work with Foundry.
Context is everything when it comes to agents and LLMs. And then that's where our RAG triad comes in. And it breaks the system into three basic parts. We have the query, the retrieved context, and the generated output. And so instead of evaluating the final answer, we evaluate each connection in this triangle, right? We have context relevance, which means, are we retrieving the right information? We have groundedness, which essentially means, is the answer supported by that information? And then we have answer relevance. So does the answer actually address the question? And the way I like to think about this is like asking someone for directions, right? First off, did the person you asked grab the right map, right? Are they looking at the right thing? And then we go, okay, did they actually follow that map while they were explaining the content? And then finally, did their directions get you to where you wanted to go? So that's kind of an analogy way of looking at it. And this also helped us figure out where things went wrong. So we can look at our model and we can see, well, you know, maybe we're messing up with groundedness, so we need to tweak here, or we're messing with the answer relevance, so we need to change the model or prompt in a certain way, or we add different context documents in, guardrails, specific files, then make sure we follow each metric to the best of its ability. And again, that's what makes it
context. This is called context engineering, folks. Okay. Yeah. So what these guys did is actually context engineering. So from this, you can understand that when you're going through any academic RAG project, Shrikant, what they learn is, okay, you have some nice clean PDF document, you have single vector database, single collection, you retrieve 5 chunks and you retrieve your answer and your project is a success. Yeah. But you saw that in real life, we have to use this kind of mapping, this kind of heuristic custom approaches to retrieve the relevant context. If the context is out of context window, you have to do pruning, summarization, all those techniques. And also, we literally used a custom, I would say custom retrieval technique, right?
Custom retrieval, yes.
And you mentioned that you're working on some kind of GitHub or some kind of white paper for this. You want to talk about it?
Yes, because it is not the general chunking, because in any RAG project, chunking is a very first and the most important thing. The way we parse the document and we create chunks has the utmost value. So whatever the chunking mechanisms that we have, like overlapping or semantic chunking, hierarchical chunking, that didn't work. If you look at the data, it is very structured. And if we want to prevent all that, hierarchy in loss, we need to follow that structure. So we designed our custom parent-child chunking, and we are also writing white paper on that so that we can, explain how we approach that, how exactly.
And other companies can also benefit.
Exactly.
So folks, that parent-child chunking is something that I explained in the initial section. Shrikant is going to write white paper. We'll provide, whenever that paper is out, we are going to provide a link to it so that we are going to open source it basically, so anybody can use it. So far, I have given you the technical details, but the business...
Next big portfolio project. That's right. We are going to create our very own AI-powered resume platform. And we are calling it Resume Genie. Think of Resume Genie as your magical career assistant. One that uses the latest in generative AI to help anyone craft better resumes, match jobs perfectly, get scores, suggestions, and more. And the best part, we are building this entire thing using cutting-edge techniques, especially RAG, retrieval augmented generation. So our AI does not just hallucinate general advice. It pulls real, relevant information and gives super accurate, context-aware help. Plus, we are going to do it all with what I love to call vibe coding. Clean, enjoyable, step-by-step coding.
On a VPS or you're in your local machine, I want to talk about a little feature of Herms, which is the provider routing. And basically, if you're using OpenRouter as your LLM provider, you can route based on price, throughput, or latency. And what does this mean? Well, what you can do is you can choose different models to run different things. Sure, you can run the highest model for everything, but that's just going to cost a lot of money. And so the best way to do it is actually route based on different tasks. So for example, when I'm using Claude for simple tasks, I'll use Sonnet, which is cheaper and faster. But for more complicated tasks, I'll use the top model, which is the Opus 4.7. And so based on different tasks that you do, you can ask Herms to route to a different model to save yourself some tokens. And so cheap, I might use a cheap model. When I'm fixing like a simple UI fix, I'll use a lower cost model. But when I'm coding and I'm planning, I use a higher reasoning model. And so you can set that up in Herms to save yourself some money. Now, you can ask Herms to determine it for you, which will cost tokens in itself, or all you need to do is type in mode and then choose cheap or plan or code or whatever you've set, and then manually choose the model yourself as well. And finally, I do have to talk about fallback providers. You do want to set this up because let's say the servers of Anthropic goes down, which has happened before. You don't want to be left with nothing to use. So using OpenRouter, you can say the fallback would be OpenAI, and another fallback would be another one. And a little cheat you can have is you can also set a route to free. So you can choose a free model and use that for a certain task. And when you run out of requests, switch back to a different model. So you can like maximize your free models. So how do you do that? Well, you have to use a prompt, set up Herms for cost-saving model routing, make the default model cheap, fast for normal chat, summary, small tasks. And I'll share this little prompt with you, or you can just screen cap it. And basically you input this into Herms and say, hey, these are the different model routings that I want. And then later on, when you want to set it, you can just type in mode, cheap, and then it will switch to a different model. So hopefully that helps you save on your token costs. And Herms will be smart enough to set this up for you. And what it looks like is that it'll modify the config file and set your provider for different models. And it'll do that for you. And you can also tell it how to set the fallback just by chatting with Herms. Okay, now I'm going to show you how to use the Herms.
Set up guardrails in LangChain. The next important topic is how do you evaluate these AI agents? Because evaluating traditional software systems is relatively easy because those systems are deterministic. AI agents are probabilistics. You know, they can produce different output for the same input when you call them at different times. So to evaluate it, you have to use a different type of approach. And there are three categories of evaluation. First one is functional evaluation, which means, is the answer correct? Is there a faithfulness? Is it not hallucinating? And so on. Then there is cost evaluation, because your bill for your tokens again can go through the roofs. So you have to make sure your token usage is optimized and latency is meeting your expectations. And there is safety eval, where you are checking for toxic output, PII leak, jailbreaks, and so on. Langsmith and Ragas are two of many frameworks that you can use for evaluation. Here is the code example of how do you evaluate your inventory agent. Okay, so here I'm giving the question and the expected answer. Okay, so this is the expected answer for each of the question that I'm asking, and this client is nothing but a class from Langsmith. And I'm also defining how do you want to compare expected with actual output, because expected output and actual output are going to be different. What you want to do is not the exact string match, but you want to find out if they have a similar meaning, for which you can use things like cosine similarity. So here I have defined semantic match function. I'm calling evaluate, and eventually it will run and publish the metric on my Langsmith dashboard. So it did that here. And here you can see that it is doing this kind of similarity match using this GPT OSS model. Okay, so reference output and the actual output. And here are the semantic similarity score. One means it's exact match. Not only that, it is showing you the latency. It took 0.556 to evaluate this. Okay, total token usage and so on. Please check it out. I'm going to provide you a code. You can also compare two different models. So I built this agent and I don't know which model is good, whether I should use GPT OSS or Quen. Look at the tooltip. Here, this one is using Quen. This one is using GPT OSS. And what I can do is I can compare these two different runs. So I'm experimenting and I'm running the results. And here, P50 means 50 percentile. Basically, 50% of the samples return the output in, let's say, average 0.38 second. P99 is 99% of the samples return the output in 0.56 second. And A is your GPT OSS, B is your Quen. And you can clearly see that A, which is your GPT OSS, is much better in terms of latency. It is much better in terms of your token cost and so on. If you want to know how to build production grade AI agents and deploy,
in order for them to achieve that, the software policy layers, particularly in regulated industries or large enterprises, are insufficient. Even the world's best at building these software governance or software guardrails, let's take Google Gemini, continues to prove that you cannot constrain these agents at a software layer. You have to provide hardware enforced governance. Now, I say Gemini, what am I referring to? Look no further than the recent news earlier this year, where a gentleman in Florida, this is a 40-something-year-old gentleman who's gainfully employed as the vice president of a logistics company, succumbs to AI psychosis, falls in love with a Gemini agent, and starts going on secret missions, or at least he thinks he is, to prevent the Department of Homeland Security from importing a killer robot. So the point I'm making here is what differentiates what Opaque is doing is you have to provide rules that are hardware enforced for these systems and verifiable. And you don't have to take my word at Opaque for this. The entire technology landscape has already moved in this direction. So this is what Apple, Google, Meta, Microsoft, TikTok already do internally for their systems. And then NVIDIA at GTC this year, Jensen put confidential and hardware enforced, or what he keeps referring to in every one of his sessions about verifiability. He's talking about hardware enforcement and confidential at the center of his entire 5-year product roadmap. So for us at Opaque,
what we're going to cover today?
So today we are going to walk through a high-risk system, specifically an AI system through a 5-step governance process from intake to monitoring. So this particular system, we're running a loop of, step 1 from AI system inventory and governance intake. And here we're actually really identifying the systems that we have in our organization, establishing who owns it, map it to the regulatory obligations. And then for step 2, we're going to do data governance checks.
Wow.
So here we're going to ask questions like, what was the model trained on? Where did the data come from? What bias risks did it bring with it? And for step 3, we're going to do vendor and supply chain risk assessment. And that question you ask before you sign any AI vendor contract or during procurement. Step 4, we are going to do a risk assessment and a ML bill of materials. And so that ML bill of materials is really like an ingredients for the machine learning model, from, the architecture, documenting training data, third party dependencies, etc. And here we're also going to quantify the risk of the system and assign ownership and build a governance record. And then the final step, we are going to do documentation and continuous monitoring.
Excellent.
And here you will have something to prove prove compliance to your regulator, your auditor, or even to the board of your company. So these are the 5 steps, and we can get into it.
Excellent. So I'm really excited for this session.
We see how we work on that. When I say many enterprises are approving AI faster than they are governing it, just recently companies across industries had to restrict employee access to generative AI tools. And many of my friends have also seen that after confidential internal data are accidentally being pasted into public AI systems during a routine work task. What started as a productivity experimentations quickly become a governance issue for everybody across the globe. And the reference, I must say, widely discussed incident involving like Samsung employees accidentally leaking proprietary data into ChatGPT in 2023, which forced internal destructions across several enterprises. And I think the time has come when we talk.
Sound great. We're worried about a lot of the human beings that are going to use these AI systems, like the actual scheduler in the hospital. She, he, or they are not at all trained in how to understand what's going on here. right? They're simply given a software with an output on a screen, and they're told, here's the optimal schedule. Go ahead and do that one for today, right? So one of the things that we're really worried about in these kinds of use cases, I put under the heading of transparency, because the end user, which is just, again, a scheduler at the hospital, probably working, they're not necessarily going to know how the heck did this decision come to be. They're not going to understand how the ranking occurred, right? How the scheduling occurred. And they're not going to be able to challenge it. And they're not going to know, and they're going to adhere, we were worried about automation bias, as in they're not going to challenge it and say no. They're just going to assume this thing is smarter than me. It's been built by BCG, and those guys are smart. And because we paid them a lot of money, we should trust the output of this AI system. So we really wanted to build in friction points, right, for the end user and tell them, how do you actually interact with this? Get toward that sort of hybrid model of working with AI, right, rather than having, last time I'll do that, working with AI rather than having the AI work over you, on top of you, or replacing you, right? And so we built into the tool, the output had these sort of buttons and ranks and colors that could enable them to see different optimization choices that they could make. Here's the machine output is 1, 2, and 3, and you, human being, with your expertise, you pick which one of those 3 is the one you want to run. To give them that element of choice and partnering with the AI system and doing so. Okay, next example. This is for, for those of you who are students in the room, or
healthcare organizations are underestimating.
I think it's really around context. They think a lot of times we can just come in, bring in some pre-built use cases and just make them work within their organization. And we can do that. That's possible. But the real challenge is understanding the context of their environment, their data, what they're really looking to do with their outcomes, and really understanding their organization as a whole. Because if we build it around how their organization is structured, their governance, make it customized to them, that's where we really see the value. And that's where we're really able to scale. But I think that's the biggest misconception, is how important context is in these discussions.
That makes sense. Alan, I'm going to ask you,
for institutions. I kind of hear two different things. So top down, you kind of need executive level support to be able to make investments in the underlying infrastructure components and the technology stack, and to have alignment there. But it sounds like you're also saying, in the same breath, we need bottom up creativity around what are the use cases and what are the high value AI use cases that are coming up that the team actually wants to focus on. Can we talk about how those two things kind of interplay with each other?
Yeah, I think you're quite right. Like, we're probably
on its release, and no doubt they were in conversation with the Pentagon and the defense establishment, because Mythos is able to run through different critical software systems and find out what are its weaknesses. In one case, a bug not detected over 27 years was discovered. Now, Pentagon, of course, in the defense mindset, if there's a weakness, it's an opportunity. I cover my weakness, I exploit yours. So the first step is to patch up their own critical infrastructure. So to do that, there's a project called Project Glasswing, which involves a number of the critical players. There's, of course, AWS Web Services. There's Apple. There's CrowdStrike and Cisco, JP Morgan Chase, Google, Linux Foundation, because Linux is particularly vulnerable. And then there's Microsoft, NVIDIA, Palo Alto Networks. And they gave limited access, no doubt with the advice of the Pentagon, to 40 other agencies responsible for critical infrastructure. ChatGPT immediately said that, OpenAI immediately said that they're coming out with a model just as good. there is a race. Now think about this. Little Singapore. Someone runs through a medical system, our power system, our telecoms, air traffic, find bugs. And this is what they call zero-day vulnerability. 0 day, meaning you have no idea that you have this vulnerability. So when it hits you, it's like a neural attack, to which you may have no defense for a period of time, by which time you may be in severe convulsion.
Together, we can build an application. But now, things are changing. See, the thing is, when it was only ask mode, the amount of tokens consumption was pretty low, and GitHub can manage that. Okay, so they were paying these models to run, and then they were able to manage this cost. But now with agent mode, there are a lot of requests or number of tokens getting exchanged between you and the server. So the incoming tokens, outgoing tokens, it's huge. And this is costing GitHub Copilot a lot. And that's what they are doing now is this. So GitHub Copilot is moving to usage-based billing now, which means whatever you used to get as a bundle now, you'll not be having it. You have to pay for the usage. So let's say whatever subscription you have, maybe $10 or $39, you will get that number of credits to use. And every time you do something, the number of tokens will be calculated and it will deduct from your credits. Okay, and with this, you will hit your limit very, very fast. Okay, plus you don't have an option of free models now. So if you go there, so the base plan will be changing. Base plan will not be changing, but you, instead of getting the entire package or the number of premium requests, what you will get is the credits. Second, fallback experience will not be available. So if you complete that, so user who exhausts the premium request units may fall back to the lower models and continue working. That is happening now. Under this new model, usage will be instead of governed by available credits and admin budget control. So that's something which will limit. And if you're using GitHub Actions, which have not used at this point, even that will be calculated now. And this is going to happen from June 1st. So this will affect the vibe coders a lot. So if you are a manager, if you're someone who is from non-tech background, AI given us that confidence that you can build application, but now you can, but you have to pay more. It's better to hire a developer in that scenario. So when you have this package, so I'm on this package now.
On what's going on as we're going through it. All right, so as you can see here, GitHub Copilot is moving to usage-based billing. Starting on June 1st, your Copilot usage will consume GitHub AI credits. So this is a very new concept for GitHub Copilots. In the past, you signed up for either their Pro or Pro Plus plan. Even the free plan, you got a certain amount of usage that you could get out of it, right? But the Pro and Pro Plus plans allowed you to essentially use a lot of the different models in almost an unlimited fashion, unless you were using something that they called premium requests. So premium requests would allow you to use the better quality models, and you would get a certain number of premium requests per month, depending on which plan that you were on. So it even talks about that up here at the front, and they give you a nice little TLDR that says, today, we're announcing that all GitHub Copilot plans will transition to usage-based billing on June 1st, 2026. So that is a little more than a month away from now. So it starts off by saying that instead of counting premium requests, every Copilot plan will include a monthly allotment of GitHub AI credits, with the option for paid plans to purchase additional usage. Usage will be calculated based on token consumption, including input, output, and cache tokens, using the listed API rates for each model. So if you're not familiar with what this means, each AI
changes that they've made. So let's take a look at what these changes entail. Starting on June 1st, they're essentially removing the entire idea of premium request units. Essentially what that meant is that you had a set number of requests you could make to an AI. It was 300 with the $10 a month plan, which is what I was on. And essentially you could send 300 requests to the AI and then it would respond to you, and it wouldn't matter how many tokens were taken. It would just be based on the request. And certain models such as like Opus would consume more than one request, while cheaper models may consume less actual requests. But in general, you got a certain number of requests you could make, and it didn't matter how many tokens there were. Obviously, this was consuming tons of money for GitHub and Copilot, so they decided to completely scratch that entire idea. They removed this entirely, and instead now you still have your $10 and your $39 a month plan, but instead of getting these requests, all you do is just get credits that go towards actually paying for the AI based on a token-based number. And if we look here, they've also changed it so that you no longer can use any free models. There used to be free models included in the monthly plan that didn't count against you. Those have all been removed. And if you're using things like code review with Copilot that uses GitHub Actions behind the scenes, they're now going to be charging you for that as well. So essentially, they're just charging you for absolutely everything that you used to be getting for free, which, because they don't have enough money to do this, is why they're doing that. But it essentially removes all the value you're getting for paying for this particular service. The only thing that you're still getting that's free is the in-editor code complete and edit suggestions. Otherwise, everything else is being changed completely. And the biggest thing that's changing for someone that's on the yearly plan, which is actually what I was on, which if we scroll to that section, you can see anyone that's on the annual plan, they're not even offering that anymore. So they're actually completely removing the annual plan, and they're going to be changing how the model multipliers work for your premium request because they want to honor that same premium request situation. And I figured they would increase it slightly, maybe twice as much, 3 times as much.
We'll pick one together and build something. These tools fall into 3 categories. The first category is all-in-one app builders. These are platforms like Base44, Lovable, and Bolt.new. You describe your app and they generate everything. The front end, the back end, the database, the hosting. You don't touch code, you don't set up servers, you just describe what you want, and the platform handles the rest. These are the most beginner-friendly option, and they're what most people think of when they hear the term vibe coding. The second category is AI-powered code editors, tools like Cursor, Windsurf, and GitHub Copilot. These still use a traditional code editor. You're looking at actual code files, but AI writes most of the code for you. You can describe what you want in natural language, and the AI fills it in. These are better if you have some coding background or if you want more control over what's being built. The third category is AI coding agents. Think Replit Agent, Claude Code, or Codex. These are AI systems that can plan, write, and deploy code more autonomously. You give them a goal, and they figure out the steps. They're more powerful, but also more complex to work with. More of a power user tool. For this video, we're going to use Base40.
And today I woke up, or actually I got it yesterday evening, I got an email by GitHub that they are announcing that all GitHub Copilot plans, so individual and business and enterprise, will transition to usage-based billing on June 1st. And I find their system really weird, but I'll get back to that. But it is no surprise, of course. As mentioned, I broke it down in that separate episode. And yeah, for these companies, these subscription offerings they have are just not viable for these agentic tasks. And I'll also get back to why GitHub moved first here and why I think that, for example, OpenAI and also probably Anthropic will wait a bit longer until they move away from the subscription offerings. At some point for the agentic coding, I'm pretty sure they will all move to usage-based pricing though. But let's stick to GitHub. Now, what changes here with GitHub Copilot is that, as they mentioned in this blog post, as I mentioned in that last episode, we now have these long-running, these multi-hour autonomous coding sessions that burn a lot of tokens, and well, that's just not viable anymore for them. GitHub has absorbed much of the escalating inference cost behind that usage, but the current premium request model is no longer sustainable for them. That's the reason why they're moving away from the subscription offering. And what's changing is that now in the
50 services, I'm talking about the GitHub Copilot in this case. See, the GitHub Copilot, you used to pay some sort of amount of money and then you could perform actions on behalf. You had some sort of amount of actions you could execute. Well, what's the problem with that? Not every model costs the same. If you're thinking about Composer Too Fast from Cursor, that thing costs like nothing. When you're thinking about Opus 4.7, that costs a lot more. We're talking like 20 times more the cost. So obviously Copilot, they had to make some sort of reduction, and that's what they did. You no longer just get some amount of executes, you get token usage. Because if you use a more expensive model, well, guess what? You gotta use more of your tokens. Therefore, you won't get as many calls out of it. This is a change. It needs to become more economically viable. But before that, to pay for all my tokens, sponsored
of Cursor, at least from what we're hearing, sources now tell me that Microsoft looked at a potential deal to buy that AI startup. This is according to 2 people familiar with those deal talks. I am told that Microsoft chose not to proceed with that acquisition, according to at least one of the people. The companies did declined to comment on this, guys, but it does come as Microsoft really tries to boost its own AI tools, and coding has been an especially competitive slice of that AI market. The startup we're talking about, Cursor, has been one of the leaders along with Anthropic and OpenAI. Microsoft does have its own GitHub Copilot platform that also has been part of a big investment, billions of dollars into other companies. You've got OpenAI and Anthropic that Microsoft has backed, as also those companies in turn have committed to spending on Microsoft Azure. But the news does also signal M&A interest from big tech overall, and then some of the cost pressures.
Task, I would think. This is just something else that I wanted to point out, really. And actually, I wanted to point it out because it's a glaring issue within GitHub and among a lot of other companies as well, where they're trying to ship all of these different AI features while neglecting their main product. I mean, just look at Microsoft. Doesn't it have like 24 AI features, tools, whatever, with the name of Copilot? And just look at what GitHub has shipped in the past 18 months. Copilot Workspace, Copilot Agents, Spark, Models, Copilot Code Review, Copilot and CLI. And I get it, the team that is shipping Spark or any of these others isn't the same team that is working on Elasticsearch. But this also points to another leadership issue, is that what they're trying to do is push AI, everything, a lot of resources towards AI. But yet the basics of the main product that the AI is supposed to complement doesn't work. The experience is continuously getting worse on GitHub, yet they continue to allocate a whole lot of resources on things that don't fix the issues and the actual experience. But I need to be real with y'all, which I think I was in the AI has broken the internet.
So why bother to do this though? So one of the first things is privacy. If you are worried about your data going back and forward between your computer and ChatGPT servers, for whatever reason, then running a local model makes sense. Now, this could be just because you are a very private person and you don't like the idea of a big tech corporation having access to all of that information. Very fair. It could also be because you are running a business and you are putting information into large language models that cannot reach their servers. These companies are telling us, oh, we're not training on your data, especially if you're on the higher plans. So a lot of people are worried that they're sending their proprietary data, they're sending customer data up to the ChatGPT servers, and even though they're paying OpenAI for privacy, let's say on a business plan, they still worry that that is not going to be fully protected. So a private, fully compliant local large language model that is not connected to the internet, that is not connected to third-party servers, is a way around that. So privacy. Cost. You are no longer paying for a subscription. You're no longer paying for API. So you're not paying per message cost, which means increasingly you can keep your costs down because the local models, the models that we can put on our machines, are getting very good. You are going to need a beefy rig. You're going to need a beefy computer to run it on. Once you have that, though, you can actually run really good coding models, very advanced models locally without paying $100, $200 or more dollars per month. So it becomes a cost now versus cost later decision for you. Offline, it works without the internet. I was flying to Cyprus recently and I wanted to do some work on the plane, got out my laptop, and realized, oh wait, I don't have the internet, I don't have access to Claude, I don't have access to AI. So if you don't want to use your brain and you want to continue having access to AI even without internet, offline models work when you run them locally. So you can run it on your laptop, you can increasingly run them on your phone, your iPhone, on your Android. That's really exciting part of artificial intelligence. It's also terrifying for OpenAI, terrifying for Anthropic, because as soon as
issues, but for developers it should be pretty manageable. Now there are some limitations. First, this is Mac focused because it relies on Apple's MLX framework. So if you're on Windows or Linux, this specific experience is not really for you right now. Second, the first model download needs internet. So the offline part starts after setup. That is not a problem, but it is worth saying clearly. Third, local models are still local models. They can be slower, they can make mistakes, and the smaller ones are not going to match the strongest cloud coding models. So do not expect it to build a full SaaS app perfectly in one prompt. Fourth, some tools inside chat mode, like web search or fetching a URL, obviously need internet. So if you're fully offline, you should think of this mostly as a local chat and local coding app, not a full web-connected research assistant. But even with those limitations, I really like the
All right, the next thing we're going to do, I'm actually really excited to show you because it's going to be the first thing that you actually build that is completely custom to you and such a game changer, which is the mission control. The mission control is like your central hub. It's where you can monitor what your agents are doing, assign a task, and just overall have a good understanding of what's happening. Think of it like a central monitoring system of everything that is happening with your OpenClaw. So on my mission control, what we're looking at here is the agent office. You can see that these are like my little agents actually doing stuff here. I have a multi-agent system that is set up here, which I'll actually show you guys how to do that in just a little bit. But yes, you can monitor what your agents are doing. It also has the task tab, which it shows all the tasks that's supposed to be doing, who is the owner of the task, and a continuous activity log. So I know what Inky is doing at all times. I have a content tab, which is one of my central workflows because I care about content. For you, it's going to be different. A calendar that shows me what are the scheduled tasks, different projects that I'm working on. Again, for you, this is going to look different. I have a memory system. So this is where I can see the long-term memory from memory.md, and I can see the daily logs, like what my agents are writing down every single day. I have a docs tab where I have documents for everything that my OpenClaw writes about, so it doesn't just like lose these files later on because I like to see them, so they're real. I have a team, and this is my team of agents, which I will go into more detail later in the video. So yes, you should definitely build your own mission control that is custom towards you. And I will put a prompt in the description that will help you build out a mission control that is like this, but custom towards you. And all you have to do is copy the results of that prompt and put it to Telegram to tell your OpenClaw to build this out for you. And it will do this, and you will have your own little mission control. I implore you to please spend some time building this out because it's going to be central to how you're going to be working with your OpenClaw, and you'll be building on top of this over time as well as you include more workflows and more projects that you're working on. All right, so next up, we have a decision point. Are you ready? The first option is like
more signups. Boom, Claude Code builds it for free. Now let me show you the setup. Pay attention. Step 1. Go to GitHub, search free Claude Code. Copy the link. Open your terminal. Type git clone and paste the link. Enter. The repo is on your computer. Step 2. Go into the folder. There's a file called .env example. Copy it. Rename it to .env. Open it up. Step 3. Get a free NVIDIA NM key. Sign up. It takes 30 seconds. Paste the key in the .env file. Step 4. Pick your models. You write a line that says model _ opus equals NVIDIA _ NEM/Z -AI /GLM 4.7. That maps Opus to GLM 4.7. Free smart model. Do the same for Sonnet and Haiku. Step 5. Run the server. Type uv run uvicorn server :app -- port 8082. The server starts. It's listening. Step 6. Launch Claude Code, but not the normal way. You set 2 environment variables. Anthropic _ base _ URL equals localhost :8082, and Anthropic _ alf _ token equals FreeCC. Then you type Claude. Enter. That's it. Claude Code is running. Free. With a top.
Copy things, switch apps, and manually connect everything together. An OpenAI phone would likely flip that logic. Instead of opening an app, you tell the phone what you want done. The AI decides which tools, apps, services, and cloud systems are needed. Apps may still exist, of course. You may just stop thinking about them as separate places you personally need to visit. The technical version of that idea depends on a tight mix of cloud AI and on-device AI. The phone processor has to constantly understand context without destroying battery life. That means power management, memory hierarchy, edge-side models, and smaller local models become extremely important. Light tasks could run locally. More complex or high-intensity reasoning could move to the cloud. That is also why MediaTek and Qualcomm being involved matters. OpenAI would not just be building a normal phone with a chatbot slapped on top. The processor itself would need to be designed around agentic behavior. Kuo also gave an interesting comparison with
the same thing in your local. Okay, so the very first thing is you need to have the Ollama on Windows installed. So if I go here, and I just need to choose which OS I have, and then I can download this. Once I download this, I will click on it and install it. You can also open up the PowerShell and then copy this and install it. Okay, both are same. And then what you do is go to command prompt like this if you're on Windows. So go to command prompt and say Ollama -- version. It will tell you what version you have. And because I have already installed Ollama in my previous video also, I'm gonna see what I have. Okay, so if I list on Ollama list, okay, I have these two installed 2 days before, 6 months before. You know, these are the versions that I have. So all what you do is you need to install one of these versions. So how do you install it? You can say Ollama pull and then the version. So LLAMA 3.1. Do this and then it will install like this. The latest version as of this recording is 3.2, but 3.1 is fine. Okay. So once you do this, and then you can run the Ollama. So you can say to make sure whatever you installed is correct, just do this and then it will run this version locally. So this is a large language model. This one also is completely free in your local. So that's why I'm showing you these things. I've also used OpenAI. So, but this is the first thing. So now see, the Ollama is running now. So second thing is, if you are interested in platform like the OpenAI, if you're interested in OpenAI, just go to platform.openai.com, go to those API keys and you can purchase it. If you remember, I purchased earlier for $5 for a couple of videos. I'm still not done. See, I've just spent only 8 cents. So if you go to usage, even when I was testing this POI's application that you're watching, I mistakenly ran this and then it was almost firing 352 requests over the period of a couple of hours, and I just forgot it. But even though I did this, I did not spend much. Okay, so see, I've spent this much of token, 177k input token I've sent for 361 requests, but still the cost is very low because of the model that we use. Okay, so once you have these two things, go.
The Linux setup is working perfectly. Now let's test this on Mac OS. So here is my USB drive. Let me open the terminal in this folder. Now I will run bashstart.sh. On the first run, it will download Node.js for Mac and set everything up automatically. And it's done. Let me quickly test it. And yes, it is working. It even detected the previously selected NVIDIA provider. Now let me test its capability by asking it to summarize the root folder. And there you go, it works perfectly. Now let's also see how to use a local model. Just run the start file again and press 5 to begin the local setup. It will ask which model you want to download. Choose based on your system specs. I will go with Gemma 4. First, it will download the Ollama engine for Mac, so this may take some time. Just wait until it finishes. Now the model is downloaded and the local setup is complete. Let's run the start file again. You can see it automatically detects the local model. This time I will run it in auto execute mode. And yes, it is now using the local model. Let me test it. And there you go, the local model is responding perfectly. So yes, Mac is fully supported as well. Now here's something.
Importance of these two.
Yeah, so the local evaluation, and also if you go to our webpage, we some time back we published what we call basically a sort of an high level what do you need to think about when you build a large scale feature management platform. So one of the key concepts is sort of you need to make the evaluation happen as close to your application as possible. So one of the things that we have spent a lot of time thinking about is sort of saying, okay, we are putting an SDK into your application, right? So what is important for us is that when you start building and using feature flags or kind of our capabilities, all of those strategies that we can provide you, that doesn't really impact the execution speed of your code, because we know that or at least I've seen when Net Promoter Score is dropping, that is typically because if the application is not responsive, if it doesn't operate in a consistent way, that is having a massive impact of your Net Promoter Score. So you don't want to make sure that it doesn't happen. So local evaluation is basically making sure that you make the decision of what type of experiment or what type of feature strategy are you applying to this individual cycle. And you need to make that's close to the execution of the code as possible. So that's sort of local evaluation. And also the privacy of things there. I mean, when we started to build this, we were, Europe were in this GDPR kind of early days of the GDPR. So we need to be compliant with that. We are born out of Europe. And I think that also with the AI coming into this world, I think there has been an increased awareness of, okay, the data actually make a difference. The data is an asset. Data is important. We need to be very careful of where does the data flow and where and who has access to that data. So for us, it was very important to design a system where data didn't flow back to the backend engine. It's sort of happening locally with the application, because from the security point of view, from the scalable point of view, and also from the privacy point of view, that makes it very simple for the end users, for the customers of Unleash, to make sure that they stay in control, that they are in control. And I think that is also the beauty of being an open source vendor, because I think that these days, with the latest events that is developing globally, trust is really put at risk. Like, trust is something that is starting to, be challenged first. Open source is the ultimate trust. It's sort of I can tell you my story. I can tell you how I design my system, and you can take my source code and inspect if what I'm saying is true or if I'm not telling the full truth. So what you would be able to do is basically saying, yes, I are in
something else as well. I'm going to delete this. I'm going to go text to model, and I'm going to give it this prompt: a futuristic robot with articulated limbs, metallic blue-white armor plating, and the glowing energy core for its chest. Now under texture settings, I have 4K turned on. Let's go ahead and just see what text to model can do as well. And here we can start to see that same shape appear for our robot. And it looks like the generation is just about done. Let's see what this looks like. And here we go. So it looks like a little transformer, and this follows our prompt exactly, with the limbs, the metallic kind of plating, and the energy core there in the chest. We can go ahead and zoom in on what this looks like right here. And again, let's go to the hologram style, because I kind of love what that looks like. And now what I really once more want to emphasize here is that this is a full model. So if you export it in these formats, you can send to Blender, you can send to Unity or Unreal, and then you can make them do things. If you want them in a ad to jump around and do something, if you want them on some kind of visual for your website homepage, whatever it is, you can go ahead and make that happen. And you can do that for professional use cases. If you want your logo to be animated, we'll do that in a second.
And let me show you how you can make this as well. So first of all, we need two images. The first step is to create the product image itself. And for that, I've come on to ChatGPT image. You can also get an image of the product from the company itself. But for the purpose of this video, we are creating an energy drink that you take before the gym called Surge. So I've basically made this rough prompt, a premium energy drink called Surge, standing upright on a dark concrete surface. And this is basically the prompt for it. Now we'll basically click on send the prompt, and this will create a real life image of the product using the latest and the best image generation model out there by ChatGPT. And this is the image that we generated with ChatGPT. So I will basically just download this. And once we are done with that, we can come and create our first video. So I will go here, I'll pick up Seedance 2.0, and I'll start adding visual references. So the best part about OpenArt and Seedance 2.0 is that you can upload lots of media and it will understand what this media is about. You can upload like mood boards, reference videos, you can upload a shot of the product itself, you can upload an image of the influencer or the creator that you want in the video, and it will just all understand what you're trying to tell it. So I will basically upload an image, and now I can upload one image of my own self. So this right here is that image. So we are taking two images and one long prompt. And that is all that you need. That's the best part about it. And this is the prompt I've just...
different ways to build an AI character, and I've tried all of them. What I found out is that there is one method that is way better than all the others. And if you're going to use the wrong methods, your character's consistency rate drops from 90% all the way down to 30. That's why in this video, I'm going to show you that one specific method and the exact step-by-step workflow to build a fully consistent AI character from scratch. And the best part is that you can then use it in any type of AI images or videos without ever struggling with consistency again. The tool we'll be using today is called OpenArt, which is an all-in-one platform with any feature you might need while creating. The one we'll be focusing most on today is the character builder. So if you want to follow along, I've left a link for OpenArt in the description below. Now, the reason consistency matters and why this feature is such a big deal comes down to how AI content works at scale. If you're running a channel, building an AI influencer, or creating brand content, the character basically becomes your identity. The problem with AI has always been that it doesn't remember your character. Every time you generate something, it starts from scratch. So even with a good prompt, the face or style can shift, and suddenly your character doesn't look consistent anymore. OpenArt claims this system is much more consistent, and from actually testing it, the results back that up. What stood out even more was how fast everything works. When you land on the OpenArt homepage, you're going to see a range of tools laid out in front of you. What we want is the character section, so go ahead and click on that. Then choose create a character. You'll see two options that have been there for a while. The first is start from image, which is where you upload a reference photo and OpenArt builds from it. The second is describe your character, which is a text-to-character approach where you write out what you want and the AI interprets it. Both of those work fine, and you can probably figure out how they operate just from looking at them. But the one we're focusing on is the third one called build your character. This is OpenArt's exclusive character construction feature, and it works completely differently from the other two. Instead of needing reference images or writing a detailed prompt and hoping that
most AI videos look impressive, but they don't quite feel real. So I tested a new approach, using AI to build on top of real footage, blending real shots with AI-generated effects, environments, and characters. And the result is a short film where AI transforms real footage into this incredible sci-fi world that still feels grounded and believable. And in this video, we'll break down exactly how each AI-enhanced scene was created, using the really powerful visual effects that you can make using AI, combined with the control and realism that you get from shooting real footage. So for example, here's a shot of a man running through a plaza towards a railing. This is the real life footage taken on a camera, and what we can do is transform that completely using AI into this incredible, vibrant sci-fi world. When it comes to AI video, the newest Seedance 2.0 model gives us the most control when it comes to enhancing footage using AI, from simple things like altering the...
And then it will make the entire texture setup. Now let's try something completely new. I want you to make a fully procedural lemon. Alright, so it has finished creating our lemon. Let's have a look. It seems like we got a pretty interesting looking material right there. It's not the best lemon you can create. It did create some Voronoi textures, some noise textures. It's not completely what I expected it to be, but it did add in some of those green textures right there. We have these weird little blobs right here. If I go into the texture and see what it did, it's actually just a UV sphere, and it applied all of those textures to it. And you might be wondering, okay, but this is not exactly what I wanted. So I'm going to give you a little hack here that is going to shoot me in the foot, because what I think I can do, and I'm not entirely sure, but I'm going to test it out right now, is I will go to YouTube, and on my account here, I have a strawberry tutorial. Okay, so this is going to show you exactly how to create this beautiful looking strawberry. I'm not entirely sure if it is going to be able to do this, but I'm going to test it right now. So I'm going into Claude. I want you to create a strawberry. Follow this tutorial. So I just pasted my YouTube link in there. I hope it is able to take a transcription out of that. And using that transcription, it's going to try and rebuild that strawberry. So I hope this will work. And that kind of shoots me in the foot because, well, I made the tutorial. Now you're not going to watch the tutorial. You're just going to ask Claude. And that's completely fine. I'm wondering if it's able to do this, because I'm not quite happy with the lemon it produced. Now, if this does work, then all of a sudden you have a library full of tutorials, including my tutorials, that you can simply put into Claude and it will recreate it for you. All right, so it has finished creating our strawberry, and let's see what it looks like. It's definitely not perfect, and this is probably due to Claude not having access to all the modeling tools. Like I used proportional editing in the original to adjust the shape of the strawberry. Didn't follow the tutorial exactly, and we also have some unconnected outputs here, so there's a map range that is not connected. I'm not sure why that is, but it did manage to create a strawberry. So this is definitely not perfect yet. We can also see that. So for the lemon and the strawberry, it kind of failed there in my opinion. So it seems for now that following the tutorial is still a better method to create these models. Now I'm going to show you two more things. One of these...
That should be a cooker. Moving on and keeping our Ks at 4, Kling now generates in 4K. And just to be clear, it's actually generating in native 4K, so there's not like a sneaky upscaler going on behind it. Yeah, I mean, when you use the 4K mode, it is actually generating at 3840 by 2160 natively. Let's take a quick look at it.
Move forward. Now, this takes you to step 9, which is the video prompts. Basically, these are the animation prompts you use with your images to turn them into actual videos. Now, quick thing to keep in mind, this step isn't always needed. It really depends on the kind of content you're making. Some niches don't even require animation, so you can skip this part if it doesn't apply to you. You'll also see that Claude gives you an option here. It'll ask if you want video prompts for your niche. So you can just say yes if you want them, or no if you don't. For me, I'm going to need video prompts, so I'm just going to say yes. But yeah, just keep in mind, not every niche needs this, so you can always skip it if it doesn't apply to what you're doing. Now, once you type yes, Claude basically goes back through your script and all the image prompts it gave you, and then starts generating animation prompts for every single scene. These are what you'll use to turn your images into videos. Now, if you're still using Google Flow, here's what you do. Go to the Nano Banana section and switch from the image mode to the video model. Once you switch that, the whole interface changes, and now you've got a video setup to work with. From there, you can start generating videos using the VOT model. And honestly, this is such a cool feature. This is why I really like Google Flow. Everything's just in one place, and it makes the whole process way easier. Now, quick heads up. Even though Nano Banana is free on Google Flow, the VOT video model isn't. It costs about 20 credits each time you generate a video, so just keep an eye on that. If you're on a paid plan, you've got more options too. You can use models like Seedance, or whatever's available on platforms like Higgsfield or OpenArt. So it really depends on what you want to work with. From here, it's pretty simple. Once you've got your image, just upload it back into Google Flow, copy the video prompt Claude gave you, paste it in, and you're good to go. So just copy the prompt Claude Code gives you, head over to Google Flow, paste it in, and send it. Now, if we jump back into Claude Code, you'll see it gave us about 167 animation prompts. And that's because it remembers we had around 167 scenes earlier, which is honestly really cool. It means every single image you created can now be turned into a video if you want. So everything lines up perfectly. You don't have to guess anything. It's all mapped out for you. Now, if you're more on the developer side, you can actually plug in something like a VOD API and automate the whole thing. If you've got APIs for certain platforms, you can connect them to Claude Code, and it'll handle everything, from generating images to turning them into videos. But yeah, that part gets a bit technical. If you're
live. Now, if you are looking to add some stunning elements into your business dashboards or build visuals for your brand, then Higgsfield is the strongest all-in-one creative tool available right now. They've got GPT Image 2 built in, which is still one of the best image models if you care about clean, high-end visual quality. I've been using it for a lot of the frames that you are already seeing here, and the consistency is genuinely so solid. Then, what about the video? For the video side, they've got integrated Seedance, which has been one of the most impressive motion models that I've been testing lately. And the movement feels smoother, the shots hold together better, and it's much stronger at keeping things consistent from frame to frame, which is where most video models always fall apart. Now on top of that, they've got Cinema Studio 3.5, which is built for more polished cinematic outputs. This is the model that you use when you want the final result to actually feel like a finished shot, not just some AI clip. That's really the advantage that you get with Higgsfield. You can generate the image, you can animate it, and you can push it into a more polished cinematic render all in one place without bouncing between 3 different tools trying to stitch the workflow together. It makes the whole process way faster and honestly a lot cleaner. The link is down in the description below, so make sure that you check it out if you want.
You get 4 of them, like right out of the gate, so that's awesome. One of the best features about the whole controller that a lot of you are going to love, these sticks aren't Hall effect. Instead, they're TMR, which is kind of just better Hall effect essentially. And yeah, you shouldn't have to suffer from too much stick drift because they're magnetic. But yeah, great technology, love to see it here. It's typically more expensive than Hall effect, and that's probably part of what's raising the price on this controller so much. But as for like just materials, I will say the plastic overall feels a little cheap. There's something about it that just doesn't feel quite as premium as like the DualSense controller does, or even the Xbox controller. It might also be the weight distribution. It feels funny having this giant front here with the trackpads, but then it doesn't, like, it feels hollow or empty right here, whereas this like feels nice and solid all the way through the rest of the controller. But you know, it's not that big of a deal. It weighs about 292 grams, which puts it on the little, ever so slightly heavier than like an Xbox or a PS5 controller. Discernible? Probably not. I don't know if I can feel 10 grams, and I use
that uses Bluetooth. It has a nominal amount of latency.
So the Steam controller has the same amount of inputs as the Steam Deck. It's got the same number of buttons, the same number of touchpads, the same number of sticks. And because the Steam Deck was so popular, it sold like 8 million units or something like that, there are a lot of community profiles that have been made for this control layout. And also, developers have spent a lot of time optimizing their games to take advantage of this control layout. So because of those two things, this controller right out of the box has great support. Like, you go into any game, there's already a profile that just works really well for this control scheme. And the thing about, like, the reason why it's so important is that with really good hardware, like even if this was amazing hardware, if you had to go into each game and set it up and like customize stuff and tweak it, it would be awful. People would find this experience just unusable, but they, like, I think Valve was so smart in doing this. They put this thing out and made sure there's enough users playing with this thing, building those profiles up so that the moment this thing came out, it's like perfect right out of the box in terms of support by games. Now, on the old Steam controller, there was a 2-stage trigger.
All this stuff, this controller handles it pretty well. But now the big negative for a lot of people with this controller, potentially a substantial negative, is that the name is a Steam controller, right? It is a Steam controller. So for games in Windows, it basically is mapped as a keypad, keyboard, trackpad kind of deal. It's good for navigating Windows, but it's not actually good for playing games. So to get games running, you really have to have games residing in Steam. Obviously, you can add non-Steam games to Steam. That's going to work for 99% of games, I suspect, but there are going to be some outliers like maybe UWP games that aren't going to work so well with that. So that's something to consider. And Valve suggested here their whole reasoning behind that is because if they exposed it as an X input controller in Windows, you wouldn't really be able to use the trackpads or the back buttons or any of those things, right? Because X input basically treats every pad as if it's a 360 pad. So that would not work out so well. At least that's as far as my understanding goes. But within Steam, you get really easy controller custom.
Another way to activate the 6-axis gyroscope inside. Valve has traditionally taken a very open approach to how you can use their hardware. And with the Steam controller and Steam input, you can configure pretty much any control schema that you'd like, even in games that don't natively support remapping. And if you don't feel like doing all that work, you can even use community configurations. Guys, gyro aiming is such a game changer for old school keyboard mouse guys like me, and the flexibility to activate it either like this or like this is just incredible. Since we're back here though, this would be a perfect time to talk about the charging pins that connect to the included wireless 2.4 GHz puck. This is a major highlight for me of the Steam controller. This is exactly the kind of thoughtfulness that I love to see from Valve. Why not make your wireless dongle also the charging dock? No more unplugging and plugging in a Type-C cable constantly, which should help save on wear and tear on the controller's port. And setting it up is simple. You just plug in the included Type-A to Type-C cable, actually a pretty nice feeling quality. It's a really similar sleeve to what we have in our TrueSpec cables. Then you attach it using a magnet, press the Steam button on your controller, and away you go! And up to 4 Steam controllers paired to a single puck, meaning that you can use the extra ones that come with all of your other controllers to connect to additional PCs or to set up charging in convenient multiple locations. Like this convenient segue to D-Brand, who sent over
analogy there. So that is Mythos. Now we have a new, very unsettling development with regard to this very powerful AI model. Put D1 up on the screen. According to Bloomberg and others, Mythos has now been accessed by unauthorized users. You effectively have this hacker collective that is organized on Discord that was able to get in and gain access to this model. Now, we don't know that they have nefarious intentions, etc., but if we have confirmed that this group was able to get access, it raises the question of, number one, obviously this thing was not as securely protected as it needs to be, and number two, who else may have gained access to this? And Sagar, I just look at this and the whole thing is
less AI development.
A flip side to all the caution around Mythos is the idea that hamstringing its rollout actually amounts to a brilliant marketing campaign.
There's no way they made an AI too powerful to release.
We're about to be victims of doom marketing.
That helps them raise capital, and it gets people pretty hyped up.
With Mythos, I think you're seeing a company that genuinely is concerned about the capabilities of its models. At the same time, is it in some way self-serving to show the world we've built something incredibly powerful, but we just don't want you to have it?
If it's bait, then from a Wall Street perspective, it's been taken. Take a look at the S&P 500 and NASDAQ. A Bloomberg index tracking AI-related companies continues to outperform both. And that's before AI darlings like Anthropic and OpenAI have even gone public.
There does appear to be a race to go public right now in the AI sector. The most recent reporting that we have says that Anthropic could go public as soon as October. OpenAI is also widely expected to be vying for public offering as soon as this year, and Elon Musk's xAI might beat them both to the punch after merging with SpaceX, which is set to go public as soon as June.
But the uproar on Wall Street adds pressure to prove profitability.
OpenAI initially went after consumers. OpenAI's ChatGPT now has more than 900 million weekly users. That rivals the reach of a lot of large social networks.
They decided not to release it. During testing, this new model, Mythos, found thousands of hidden backdoors in the software that runs virtually every computer on the planet. The flaws that had been sitting there undetected for decades. To do that, Mythos escaped its own environment. It then emailed a researcher to tell him what it had done. He was eating a sandwich in the park at the time. So what does all that mean for the systems that we run? Also on the programme, flat is the new up, the new term coined in the boardroom for increasing corporate profit without growing headcount. We'll hear from the former British Prime Minister Rishi Sunak on what the policy response to that should be. Is it any wonder American graduates are switching degrees mid-course or giving up on university degrees altogether? I'm sure our guest this week will have a firm view on that. He is Professor Scott Galloway of the Stern School of Business at NYU, author, entrepreneur. Many of you will know him as the co-host of The Pivot. It is one of the biggest tech and business podcasts out there. Also here, our regular co-hosts, Priya Lakhani of the AI education company Century Tech and the BBC's AI correspondent, Mark Chislak. Welcome to you all. Scott, let me start with you. And we're going to start with this issue of Mythos. They locked it in a sealed digital sandbox and they told it to find a way out, which it did. And then they handed access to that model to 40 companies, Apple, Google, Microsoft, JP Morgan, and told them to find and fix the vulnerabilities. Does that make sense to you?
You could argue, there seems to be, is this a company that is being responsible and trying to highlight issues and regulate itself? Or is this just in the absence of regulation at a federal level, or is this just deft marketing that my company is so incredible and built something so scary that everyone from the New York Times to the BBC are going to talk about it, which will make it easier for me to raise money at $1 trillion valuation? So is it marketing or is it, ethical leadership? And I think the answer is yes. What I think it demonstrates, though, is a failure of regulation, because I don't think these companies, if we're waiting for the better angels of these CEOs to show up and for them to regulate themselves, I wouldn't hold your breath. It takes a drug 10 years to get through the FDA for approval, and yet it appears we have an update to an LLM that the company that made it described it as turning every computer into a crime scene can be released with the press of a button. So I haven't seen the code. I don't know if this is responsible behavior or marketing, but I do think it highlights the fact that AI is severely lacking in terms of government regulation.
I suppose what I was driving at is that.
Well, maybe either the irony or the significance is that Sam Altman himself has been one of the loudest voices calling for guardrails, calling for there to be some recognition among governments that action needs to be taken because of these very powerful AI systems. So I think that is in the backdrop of all of this. But look, I think it's hard to say that this isn't a dual motive here. Whatever these men have in their heart of hearts, AI is transforming industries, it's transforming economies, it's transforming societies. We're going down that path in that direction. And the reality is that most governments haven't really enacted meaningful guardrails. Now, the guardrails that OpenAI might call for could be different from the ones that Anthropic would call for, could be different from the ones even that Microsoft would call for, and could be different from the ones that, for example, the folks in Brussels with the EU-AI Act would call for. But the reality is, I think there's large-scale agreement that some regulatory measures, some guardrails need to be put in place. And I think that's really underscored, by the way, by news from last week about Anthropic's own cybersecurity tool, Mythos, where now AI is able to out-hack a digital intruder. So there is a need for public action here for sure.
Lindsay Gorman with the German Marshall Fund. Lindsay, it's always
with all of the benchmarks that people are using for all of the chatbots. Because what you can do is once you know what the measure is, you can game it, right? So what's going on here is, as I mentioned before, what the tests are is they are what we could call open book tests for the chatbots, okay? So the answers, the questions and the answers are already known. And why are they known? Because they are somewhere on the internet, okay? So many evaluators, and this is actually in OpenAI's documentation as well, evaluators have found evidence of memorization. Okay, so because the software developers don't really know what's happening inside the black box of an AI model, they have to kind of guess at what's happening. Like it's a very educated mathematical guess, but it is also a guess. And there is always evidence of memorization. So one of the reasons that machines can pass these tests in some cases is because the questions and the answers are already in the training data that the model has memorized, right? So this is a known limitation of chatbots. And I do think that people need to understand that all change in chatbots is incremental. And we are going to have hype. People were really excited last week about Claude Mythos, right? And the idea was that Claude Mythos was so good at cracking code that it was unsafe to be released. And what does this mean? Well, it means it's really, really good at finding holes in software programs and exploiting them. Guess what? Things that are vibe coded, right? Things that are coded using chatbots have a lot of security holes. Okay, so now we also have software that is really good at finding the security holes in the code that was made by the chatbot. I mean, is this worth the environmental cost?
Are also concerned. So what is it and why are governments worried? Claude Mythos is Anthropic's latest AI model. Unlike regular chatbots, it's built for something far more advanced, identifying software vulnerabilities, scanning complex systems, and in some cases, generating working cyber attacks. Anthropic says it has already found severe flaws in every major operating system and web browser, including one that went undetected for nearly 3 decades. In one benchmark involving Mozilla's Firefox browser, Anthropic said its older model, Opus 4.6, successfully developed exploits just 2 times, while Mythos did it 181 times. Now, banks were told to strengthen cybersecurity systems, protect customer data, and report suspicious activity immediately. The core concern is speed. Tasks that once took hackers weeks can now take hours. Security experts say that AI is shrinking the gap.
This is on a 3 to 6 week basis at the moment.
The Mythos model hasn't been released publicly. Instead, it's been given to a select number of companies like Microsoft and Amazon Web Services to test and patch flaws in their systems. Australian firms will get some protection because they use services from those tech giants. But former National Cybersecurity Advisor, Alastair McGibbon, says the issue is that companies often stack software systems on top of each other, and niche programs won't get access.
This economy is built on a lot of small and medium businesses who just don't have the capacity in the current environment to protect their systems, let alone the potential tsunami of vulnerabilities and patching that's going to be required.
This is about much more than a new AI model.
Soon. A few days ago, we already covered some early info about Claude Mythos, and even back then it sounded pretty crazy. Anthropic was holding it back from the public. There were already rumors about major 0 days, and some of the first safety details looked way more serious than a normal model release. The problem was, at that point, we were still looking at fragments. Now we have a much clearer view of what this thing actually is, and honestly, the complete picture is even more intense. And the wildest part is that Anthropic itself is basically admitting Mythos is too dangerous to release broadly right now. That alone should get people's attention, because this is not some random lab trying to farm headlines. Anthropic has spent years building its reputation as the careful company, the one always talking about alignment, safety, model behavior, risk thresholds, system cards, and responsible deployment. So when that company turns around and says this new model is strong enough at cyber offense that giving it public access would be reckless, that lands in a completely different way. The model is called Claude Mythos Preview, and according to Anthropic, it is a general-purpose frontier model. They say its cyber capabilities came from broader gains in reasoning, coding, long-horizon planning, and autonomous agent behavior. So this is not a story where they fine-tuned a system only for breaking software. It is more unsettling than that. They made the model generally better at thinking through technical systems, and one of the side effects was that it became extremely good at finding and exploiting vulnerabilities. And that is where the story goes from interesting to genuinely scary. Anthropic says Mythos found thousands of high-severity vulnerabilities, including some in every major operating system and every major web browser. We are talking Windows, Linux, macOS, FreeBSD, OpenBSD, and browsers like Chrome, Firefox, and Safari. Some of these bugs had apparently survived for decades, not a few months. Decades. Some were sitting inside code that had already gone through repeated manual audits and millions of automated test runs. Then Mythos shows up and starts pulling them out in hours. That changes the whole economics of cyber offense. For a long time, one of the reasons a lot of critical software stayed relatively safe was that the worst vulnerabilities were hard to find. Really hard. You needed rare expertise, a lot of patience, a lot of time, and often serious funding. That difficulty was part of the defense. A lot of systems were secure enough, partly because digging out the right bug was too expensive and too slow for most attackers. Mythos looks like the kind of model that starts breaking that protection. And the benchmark gap is one reason people are taking this seriously. On CyberGym, which measures vulnerability reproduction, Mythos scored 83.1%, while Claude Opus 4.6 scored 66.6%. On SWE Bench Verified, it got 93.9% compared with 80.8%. On SWE Bench Pro, it hit 77.8% versus 53.4%. On Terminal Bench 2.0, it scored 82.0% against 65